So let's say you're looking to buy a new car, which we'll say is a BMW M4, which is this car right here in the picture. And to buy the car, it'll cost you a total of $70,000. So write that right here, $70,000. Okay. Now at the same time, let's say someone has approached you for a 1-year loan for $70,000 as well, except this will pay 10% interest on top of the principal. So we'll put this 70,000 here, and then we'll just put at the 10%. So if you choose to loan out the money, you'll have nothing left to buy the car with, but you'll have an extra $7,000 of interest at the end of the year. Whereas if you spend the $70,000 on the car, that's all you'll have. You'll just have the car at the end of the year. So I'll put the $7,000 of interest right here. So at the end of the year, you'll have a total of $77,000. So how does this relate to opportunity cost? Well, opportunity cost is what is given up to pursue an alternative option. So if you think about our example here, the cost to buy the M4, the BMW M4, is the $70,000 in normally costs, plus the additional $7,000 in interest that you gave up from deciding to buy this car. So had you decided not to buy this car, you would have had your $70,000 from what you originally had, but what you gave up was the $7,000 in interest in order to buy this car. So we would say in economics then, the actual cost or economic cost of buying the car would be the $70,000 it normally costs, plus the $7,000 in interest that you gave up, because that is the opportunity cost of pursuing or deciding to buy this car. So in total, the cost to buy this car is $77,000. Again, in economic terms. So it's the $70,000 plus the $7,000. So now we're going to move on to the PPF and relate this idea to opportunity cost. So if we look at the student's PPF again, we can see that I've cleaned it up here a little bit, but it's still the same information as before. We can see that the student faces trade-offs between how many assignments they can complete and how many chapters they can read. We already know that. But for argument's sake, we're going to say that for our example, the student is always efficient with their time, so the amount of work that they complete will always fall on this blue line right here. And given this, we can now see the opportunity cost of either an additional assignment completed or a chapter read. So going from 4 to 3 costs 0 or 5. 0 and 5 chapters, going from 4 to 3. And now hypothetically, we're going to say that the student is at an output level, we'll say 5-3. So 5 chapters down here and 3 assignments. And we're going to say that they want to finish an additional assignment because all their assignments are due this week and they want to get them done. So the student would then spend all their time completing assignments. As a result, as a result, they'd have no time to read chapters, because we know from going from 3 assignments to 4 assignments is going to cost us 5 chapters. Okay, and obviously that's easy to interpret from the T-chart, but if you want to just look at it from the graph, which is probably a more common way to be examined by, so we saw that we were at 3 assignments and 5 chapters before, and we wanted to increase from 3 to 4. So at 3 we had 5, and then once we move up to 4, we see that we're at 0. So our opportunity cost is the 5 chapters that we could have otherwise read had we not allocated our extra time to that 4th assignment. And the same principle can be applied to any PPF using any 2 points. Just take your starting point. So again, I'll just choose an arbitrary number. Let's say 8 chapters and 2 assignments. It's not exactly perfect, but still you're hopefully getting the idea. And let's say we're just interested in increasing chapters read this time, and we want to know the opportunity cost. So we were originally at 8 chapters, 2 assignments, and we're going from 8 on the x-axis to 11 on the x-axis. And we were originally at 2. The y, which is assignments in our example, is 2, but more generally, it can be called y. So our y fell from 2 to at the point 11, so when we increase from 8 to 11, our y, corresponding y, is 0. And therefore, we know that the opportunity cost of increasing our chapters read from 8 to 11 is then these 2 assignments that we gave up or we gave up by deciding to pursue an additional 3 chapters during the week to read. So just again, more generally, look at your X value. It doesn't matter whether it's chapters or whatever it is. Just look at your X value or your Y value, wherever you're starting, and increase or decrease. It's probably going to be increase, though, if it's opportunity cost, because you're going to increase something and you want to know what the cost was to increase it. So take your starting value of whatever you're trying to increase. Let's again, we'll just choose a random point here, 4, and we'll say 3.5 assignments. Let's say we want to increase our chapters read to 9, let's say. So we're at 3.5 when we're at 4. Now we're going to go all the way up to 9, and we're going to say that we're at roughly 1.5. So we were at 3.5, and after we increased, we're now at 1.5. We're saying roughly. So we know that the opportunity cost of increasing our chapters read by 5 costs us 2 assignments